Okay, so very quickly, we can move on to 4.5, estimation of the population total and proportion. All right, so what we need to know is that from the population, we carefully divide them into different strata. We can perform a simple random sampling within each of the stratum. So we can estimate the mean. Similarly, we can estimate the proportion and the total. So for the formula, you can also divide the formula by yourself. The population total tau is indeed equals to n times y bar. Y bar is the population mean, and that will be the unbiased estimated given by tau from stratified and random sampling. Okay, so y bar estimated from stratified random sampling, which is little y bar, and simply multiply by population n would be the unbiased estimated for tau, the total. So in that case, 4.5 is indeed equals to the stratum average multiplied to the size. So this would be the stratum total, adding up all of the total number of stratum at the end. That would be the unbiased estimated for the total. The variance, let's just talk about the estimated variance. So again, that becomes the variance of each of the stratum, adding up together. Refer to example 4.2, estimated total number of hours per week for the household in the county. So we estimated for the entire population, that's about, on average, each household spend about 27.675 hours watching TV. Then now we have 310 households. The total number of hours simply is just to multiply by 310. And we have the estimated variance of the average, then multiply to the n square is indeed the estimated variance for the tau total. Okay, taking square root, multiply to the confidence, the critical value under 95% confidence interval, then we construct the 95% confidence interval for the population total. Okay, on the proportion, it says that under each of the stratum, we asked whether they have watched a particular show like Oscar. Okay, so 20 households, 16 of them watch it in town A, town 1. In stratum 2, out of the 8 sample, 2 of them watch Oscar. And the stratum 3, 6 out of 12 watch Oscar. So we have the proportion estimated for each of the stratum. Okay, again, we can add up the proportion weighted by the population size. Okay, so I need to emphasize in here that we are adding up the proportion, or we're adding up the mean for each of the stratum, but weighted by the population size, not the sample size. Okay, so we need to make sure we're weighted by the population size, capital N1 out of n, capital N2 out of n, etc. If we are weighted by the sample size, this is a different story. Okay, so make sure that we are adding them up weighted by the population size. The estimated variance, again, we are adding up the variance because each of the tongue, they are independently distributed. So we collect the data independently, so we can add up the variance for each of the proportion estimate, weighted by the capital L square, or we can simply use the NL square multiplied to the variance. Okay, so like this. Okay, so for the estimated variance, we can treat it like each of them like a simple random sampling. So for this would be replaced by the finite population correction factor multiplied to the sample PL times 1 minus PL divided by NL minus 1. Okay, so if you're not sure about this equation, you need to refer back to chapter 3 for the proportion estimate. Okay, then we add them up. Add up all the variance for each of the stratum, weighted by the population's capital WL square. Advertising firm wanted to estimate the proportion of the household that watched the Oscar show. So we add up 0.8, 0.25, 0.5 by the population weighting. This is about, overall is 0.6. We can also calculate the estimated variance for each of the stratum. That is the finite population correction factor multiplied to P times 1 minus P over N minus 1. Adding them up together, weighted by capital WL square. Or you can separate the capital WL, like notes here, with the population size square multiplied to the estimated variance, adding them up together, and then divided by a common factor of the overall population size square. We can construct the confidence interval for our point estimate, like how we did previously. The bound of error, look at this example, 0.0045 multiplied to 1.96. This bound of error as relatively to the point estimate 0.6 is quite large. So we need to think of some way to reduce the bound to make the estimator more precise. How are we going to do that? We need to improve our variance estimate by either increasing the sample size or etc. Okay, so in the next section we will talk about the sample size determinations.